There's something meditative about the last 45 minutes of a night flight. It's a sense of calm and energy at the same time. When you descend through the clouds and see the faint lights of the city below, you really have a moment of peace to reflect on your trip and whatever is next, a new adventure, heading home, or meeting friends or family. You can feel the pulse of the city as you get closer, the lights becoming brighter as you come in from above. This pulse, it brings us together and makes us feel a part of something bigger than ourselves. And if we imagine just for a moment that each of the lights below, in sync with each other, turn on and off once every second, the pulse of the city would truly become visible. A heartbeat every second, each flicker representing the movement of millions of people around their home on Earth. This pulse, the lights, and the heartbeat of this city is something that goes on every second around the world across the network of Amazon Web Services data centers. 500 million API calls all to one AWS service that manages identity for all customers, spread worldwide in 26 regions of data centers, each the size of multiple football fields, stacked with thousands of racks of servers, powering everything in our society. It is the heartbeat of the digital world, and it's growing closer to us every day.
Really? Why is this really so important? It's because IAM routinely handles 500 million API calls a second.
To help gain a grasp on 500 million API calls, if we assume a city has a combination of 5 million houses and buildings, and on each building some 100 lights, we get a total of 500 million lights that we see from above, all turning on and off once a second. Those lights, every second, is the pulse of AWS on a global scale. So what is cloud computing, and what is an API and service? Everything in our world today is some function of turning the physical into the virtual. Just look at some of these examples of what happens in 1 minute on the internet. Around the world, people have streamed 694,000 hours of YouTube content in the minute you have been watching this video. 148,000 Slack messages. It would take you a lifetime to read all of those. Our digital world is expanding exponentially. There's enough content created across all platforms every minute to last an entire lifetime. Beyond the internet, we continue to automate away physical human work, such as manufacturing and driving with complex robotic fleets and assembly lines. Every single one of these examples requires computers and servers, and all of their components, to input, process, store, and output data. Right now, there are only two ways for a company to handle these workloads. One way is to build a physical data center warehouse, buy servers, network all of the equipment, and put it online to support operations of whatever it is in question. The other option is to outsource every layer of complexity in this operation to the cloud, which is run in large part by Amazon, Microsoft, or Google.
But the requirements for IAM are unprecedented. We literally have millions of AWS customers, over thousands of different types of resources, hundreds of AWS services, and they're spread across over all of our regions, our zones, all the way out to the edge. And so the requirements for IAM are mind-boggling.
Amazon Web Services has more than 200 services, things that let customers create and manage servers, create and manage databases, and facilitate any number of computer actions, all from thousands of miles away from any computer. An API call represents a request and response of data, something that asks Amazon Web Services to do something to a resource, for example, insert a database record or scale up a pool of servers. In the case of 500 million API calls to the Identity and Access Management Service, AWS is offering a scale point for giving insight to a service that is routinely invoked in tandem with a call to any other API. So not only does AWS process more than 500 million API calls per second to verify authorization, but they then handle the functionality associated with every API call in terms of what it represents in managing resources. Cloud computing is on pace to be $1 trillion a year market by 2027, and as such, it is addressing critical problems in society. To quickly understand the problems that cloud computing starts to address, let's look at a brief example of a new IT project. Any new IT project today requires some combination of compute, storage, and networking, and there are two ways to accomplish this. Option number one is to build a data center, if it doesn't yet exist, estimate all of the hardware and infrastructure that is needed, order all of the components, set up the infrastructure, and network everything into the data center. And this is just to start the project. From there, the product managers and software engineers will work together to create the new application, write code to connect the application with whatever storage, compute, and networking infrastructure was provisioned, and create any testing infrastructure in a deployment suite. Finally, the product team can write the new application code and ship the project. All of this requires large upfront capital investments long before any value is delivered. And for startups who may not have a data center already, the options would be even more limited. Option number 2 offers an on-demand model. AWS, Azure, and GCP, or any other cloud provider, already have suites of services that can be leveraged from day one. While some level of capacity planning and plumbing and infrastructure code is still required, the software engineers can get started on day one writing application code. This leads to faster time to value for all of the projects and reduces any upfront costs that were required for procuring infrastructure and hardware. This idea of outsourcing to the cloud is just the tip of the iceberg of all of the other problems that cloud computing solves. Data centers also require maintenance, a costly endeavor, especially as more and more come online across the globe. And scalability is an incredible source of pain that customers solve with cloud computing. What happens when a new application receives more traffic than anticipated? How does a company immediately add more servers to its mix?
I'm excited by this slide. This is the first time this has been shown outside of Amazon. It originated from actually it was an internal technical presentation done by Brad Porter. I fell in love with it. This slide is absolutely wonderful. What it shows on the x-axis is of course time. You can see events happening, Prime Day 15, the fourth quarter, Prime Day 16. See, wow, Prime Day 16, pretty big deal. On the y-axis, it's virtual servers. So we've got virtual servers on the y-axis. They won't let me show you the y-axis. It did exist internally, but I will give you a scale point. I'll give you a scale point. If you walk down there and look at Prime Day 16, that is tens of thousands of servers. Tens of thousands of virtual servers brought online just before they were needed. They delivered the goods and they were brought offline as soon as they weren't needed anymore.
Failover, redundancy, and uptime are all other factors that any enterprise must consider when running their own data centers. These are all just a number of problems that any company must consider, and I'll link a full list of considerations in the show notes below. What is next for cloud computing? Matthew Ball is a prominent venture investor, author, and strategist. He ran global strategy for Amazon Studios and has written extensively about the Metaverse. His writings have been so influential that Mark Zuckerberg, after reading his theses, changed the name and direction of Facebook to Meta. I'll add some links in the show notes below to more of Matthew Ball's resources. His essays have impacted strategy at companies from Disney to Coinbase. The overall theme is that the digital world transformation is just getting started, and every company is taking notice as we see the shift to the Metaverse. It's also worth taking a brief step back. Dr. Jim Al-Khalili is an award-winning physicist, innovator, and teacher, and has a number of great YouTube videos that I will link below. Just one I want to highlight is the notion of information and its evolution in our fabric of reality. Hundreds of thousands of years ago, we were all just cavemen, grunting and gesturing to articulate communication. Eventually, we put sound effects together with symbols and formed the very first written languages, formed over tens of thousands of years. Today, in less than 100 years, we have added an entire compute layer on top of electricity, a global digital network where every single written word, sound, and visual can be expressed as a series of ones and zeros and transmitted at the speed of light around the world. This process is only growing exponentially larger. The amount of data created this year will be larger than the sum of all data ever created from the beginning of time through the year 2016. AWS started its cloud computing offerings in 2006, Microsoft Azure in 2010, and Google Cloud the latest in 2015. In just 15 years, the market has grown to bring in $200 billion per year, with projections to be at $1 trillion in just 5 more years. At this scale, the operations of these businesses are staggering.
I always start with this slide. I'm in love with this slide. We update it, but it doesn't matter. If we never updated it, if we left it the way it was 3 years ago, it'd be wonderful. This is a crazy number. Think what this means. Just imagine, forget about all the innovation, forget about all the things I'm going to talk about today. Just imagine figuring out how to do this. What you need to do is you need to get all the component manufacturers delivering to the server manufacturer. The server manufacturer has to build boards, assemble servers, package them up, test them, push them into the supply chain. The logistics channel has to deliver them to their data centers. Trucks have to back up to the right data center, deliver racks. There has to be enough data center space built. There has to be networking. There has to be power. The servers got to be just installed by by technicians, and it all has to be brought up. And then we do it again tomorrow. This is amazing. I'm just shocked at what the team's capable of doing.
That video is from 2016, more than 5 years ago. AWS is on pace to bring in $60 billion in 2021, and they're doing it with 30% operating margins and continued 30% year-over-year growth. Back to Matthew Ball's analysis, there are so many industries that will benefit from the digitization of our world, and sectors that will change dramatically over the next several decades. Compute, hardware, networking, and blockchain technologies are just examples of this. Some of the next big trends in cloud computing are edge computing. As devices proliferate, how can data be processed and stored closer and closer to users and their applications? 5G, enterprises are building their own high bandwidth, low latency networks. Vertical chip integration, with everything turning into a device and more workloads requiring specialized compute requirements, the tech giants are already investing billions into making their own chips. And artificial intelligence. ARK Invest estimates we could see $14 trillion in enterprise spend on AI in 2030, and the big tech giants continue to layer on machine learning and AI capabilities to the cloud. We'll take a look at some of these trends and areas of investment in upcoming videos. Of course, the big question now is which company or technologies will prove the most lucrative from an investment standpoint. Whether it's semiconductors companies, cloud computing giants, or specialized companies developing the next advances in application-specific AI, there will be several winners in this space over the coming decades. We'll dive into one bottom-up investment metric for cloud computing in the next video, so be sure to like and subscribe if you find this content interesting or helpful. As always, thanks for watching, and see you in the next video.